Okay, the first part of this video is addressed to almost every single person in here. From the quiz, there were 2 major common mistakes. After we go over that, I have a list of things that we're going to go over in class today. Some of this will be directed at you personally. Some of it will be to everybody. And I'll tell you as we go who needs to listen. If you are in the category where you don't have to listen for a certain question, that just means you're working on your review at your own pace. If you're in the category as you need to listen, then you need to have this in front of you and doing it with me. This is a goal to pass this next test. Some of us maybe have a goal of getting a B on the next test. Some of us have a goal of getting an A on the next test. Whatever that goal is, nobody in here should have the goal of failing, because you can easily do that. That's not a goal. Okay? So reviewing common mistakes on the quiz, the first common mistake was question 6. And it said, let the graph of G, I just copied it there. If you didn't write down anything about question 6, let the graph of G be a translation 3 units right, 4 units up, followed by a reflection in the x-axis of the graph of f of x equals x squared. We're going to write the rule, identify the vertex. So the majority of you in here had no problems of doing the first part of writing the rule, translation 3 units right and 4 units up. Some of you did have problems. Majority of you did not. So if you're looking at your answer, hopefully you wrote it down on your paper. You can compare it to what I would do. If you are not looking up here, I am concerned. If you can't see, I've got lots of empty desks right now. So move. All right, we've got a translation 3 units right. Right is horizontal. Where is horizontal? Inside. And when we do horizontal, that goes inside. We also think opposite. So I will have my halfway done. So like h of x equals on the inside of the squared. On the inside of the squared, we have x minus 3. So I'm doing opposite of going right. Then and then 4 units up, the majority of you got that part down. Outside, common sense, plus 4. That's the first step. So I'm going to ask us to visualize this while we go through it. 1, 2, 3, 1, 2, 3, 4. We've got a vertex at 3, 4. And this guy's going to open up. But we're not done. This is just like halfway through. So the second part says, followed by a reflection in the x-axis. So on my graph, it needs to reflect over that x-axis and end up down here. It needs to be a reflection, so it's going to open down now. All right? What a lot of you did was you're like, oh, reflection in the x-axis, here goes, and then you wrote down that answer. All you did was stick a negative up front. That's not correct. Because if I look at this negative up front, my vertex would be 3, 4. Is that this vertex way down here? No. This vertex is not 3, 4. So what we're doing wrong is we are trying to take shortcuts where there aren't shortcuts. When we have h of x, sorry, meant to make that blue. H of x equals x minus 3 squared plus 4. And you guys say, well, it's a reflection in the x-axis. That's on the outside. It has to be on the outside of the entire function. And we have to distribute. That negative sign does not go inside of the parentheses because it's only vertical, but it goes to the front of those parentheses and to the 4. To take that positive 4 and make it into a negative 4. That's where my vertex should be. So this would be g of x. So that's what happened, is a lot of you wrote the answer with just the negative out front and didn't distribute it. And then because you had that answer wrong, then you had the wrong vertex because you went off of a wrong answer. So if that was you, if that was the work that you showed, if you had those answers, I gave you 10 out of 15 rather than 0. But we need to think past stick a negative out front. Okay, we've got to actually think that's got negatives got to affect all of vertical things. All vertical things get that negative when it's a vertical reflection. So the what's it called? Thingy. Vertex would be 3, -4. This is not addressed of everybody, but so many, not so many, too many, I should say too many, not so many, too many people did not go opposite. Too many people did not know that major basic thing. I still don't understand why people who are failing do not have their eyeballs glued up here. Fix it. Do something. I am not going to pass you if you do nothing. I'm not going to pass you. You're going to pass you. You're going to earn it. Okay. The next thing that I want to say about the quiz is not necessarily that people did something wrong, but they didn't follow what we had been learning in class. So you had to find your y-intercept and your x-intercepts on the quiz. And some people were like, I'm really good at graphing, which I appreciate. And they went over to the graph and they graphed the equation. They looked at the graph and they wrote their x and y intercepts and got them right. I appreciate that because you're using a skill that you have. I did not realize so many people do that. Our goal is to learn other ways besides just looking at the graph because I don't want to have to graph it every time. And some of you graphed it wrong. And because you graphed it wrong, you had the wrong answers. Now, Ms. Criswell has the ability of seeing into the future. Oh, just kidding, just like math future. I know what you're going to learn next. You don't know what you're going to learn next. So when I say we're going to do this algebraically, I'm saying that because we're going to do it now with easy answers where there's x-intercepts at like 1 and 4, where in the next chapter, you aren't going to be able to look at this graph. I have just an example. This picture does not match that equation. It might, but I don't think it does. But I'm giving you an example of how if you graph this blue quadratic, can you look at that and know what the x-intercepts are from that picture? So x-intercepts aren't always going to be nice, easy answers. So we need a backup plan of how can we solve them when they're not easily found on the graph. So I wanted you to learn that now when they're easy answers so that when we go and do the hard ones, you at least have the process down. So I'm going to go over the process of finding x-intercepts right now, again, with a made-up question, which you're more than welcome to copy down on your quiz so that you have something to go off of, because some of you did not know how to do the x-intercepts. So I made up a question, and I'm just going to go through the process again. So like I said, you can copy this down. If you sit here and you're daydreaming, you're going to have a problem because you're not going to hear it. But I am making a video, so you can always go back and watch the video if you want to. So finding those to find the y-intercept algebraically, so not looking at the graph, to find the y-intercept, what do? We plug in 0 where? Plug in 0 for x. To find the y-intercept, you got to make x 0. Our answers for the y-intercept are going to be 0, comma something. So you're putting the 0 in for x. Some of us put it in for y. And then you don't get the right answer. To find the x-intercepts, we plug in 0 where? For y. But what if there is no y? Like, what if there's an f of x, like in my blue example? So you would make the whole thing 0 if there's an f of x, because that is y. And your answers will look like something, comma 0. The y value is 0. So here's an example of how we could find the x-intercepts. I would make the y, which is this side, 0. So I still have an x in it. I have to get x by itself. This is where you have to solve. This is where you have to do things to both sides. because x is not by itself. So what do I do first? I do what, hon? Okay, all I can hear is both sides. Oh, add 6. Yes, that is correct. I just couldn't hear what you were saying. Add 6 to both sides. So I'm going to add 6, and my pen did something weird. Okay. Add 6 to both sides. So this would be a good thing for some of you to have written down as a, I still don't know how to do this. Let me take some good notes on it. So I got rid of that last number, that minus 6. I added 6. It's on the other side now. What's the next thing that we do? Divide by 2. If there is a number in front, that's your next step. Divide by 2. Yes, some of you did it in the wrong order. So now I have 3 equals x plus 4 squared. What's the next thing I'm getting rid of? The squared, and we do that by plus minus square root. So the squared and the square root cancel out. I get plus minus square root 3 equals x plus 4. So you will not have one that is like this on your test. But I did this today because can I take the square root of 3? What times itself is 3? Some horrible decimal. And you aren't going to come up with it unless you use your calculator. Square root of 3, you should not know. Well, I don't know. Somebody might know it by heart, but nah, we don't know the square root of 3. Okay? So if you were doing this in chapter 3, which we're not in chapter 3 yet, we would keep solving this. I'm just trying to show you that you aren't always going to get nice answers. So this is why we have to do it algebraically. What we would do is we would subtract 4 next. And we would have the negative 4, and we would have plus minus square root 3. I can't add that because I don't know what it is. And then from there, you have 2 answers. Both of them would have a negative 4. One would have adding that, and one would have subtracting that. Okay, again, you won't have any that hard on the test. Yours will be nice, easy answers that can square root. This is still the process. I did this for those of you that are just using your graph. It's not always going to work. It just only works through this chapter. That's it. Okay, so that's mostly the common mistakes that I saw on this quiz. If you had more mistakes than that, you got to start asking me questions. I can't go home with you and I can't be like, let's do a private tutoring session. That's not my job. So you got to reach out and be like, I need help. Okay?